Welcome back, and I'll be talking about improper integrals. So what are improper integrals? There are several main types, but let's just start with the ones that have limits that have infinity. So these limits, the limits of the integral include infinity. So if you have an integral of something that goes from a to infinity f of x, or if you have a going from negative infinity to b, so a and b are real numbers here, right? Or if you have actually even from negative infinity to positive infinity, these are the three types of integrals that might have infinite limits, and these are all three of these are improper integrals. So what you have to do to solve these improper integrals is that you have to take a limit of this, and you have to take a limit as, now and you have to replace this infinity with a real number that approaches infinity. So you can replace this infinity with, let's say, b. So as b approaches infinity, and then you do the same thing. So from a to b, the same integral, and you just solve this out as you would any other integral. Excuse me, and you just solve it out as any other integral and just use b as a limit as b approaches infinity. So you can do the same thing here. So you can say as a approaches negative infinity, so from a to b. And the third one is slightly different. For this one, you have to split it up into two parts and take a point C, alright, or anything. Just take any point, and we'll just say where C is any real number. And you want to split up this negative infinity to infinity interval, right? Very large interval, and you want to split it into like two parts. And when you split it into two parts, you'll have something going from negative infinity to c, and then from c to positive infinity. So what you'll end up doing is taking the integral from negative, just what I said, to c, and then the other one from c to infinity, and then you'll go back and then you'll use these two things that we mentioned up here and apply them to this, because this itself, these two are two separate improper integrals again, but now you'll just apply the limits to both of them. So these are one set of improper integrals. Let's go to the other set. So the other types of improper integrals include functions that approach infinity at a point. So let's say a function like, I don't know, like this just starts approaching infinity at a point like c. And so what you do, and if you have an integral of that function from a to c, how would you solve it? So that's the other type. So say you do have something, right? So you have an integral of a function a to b f of x dx, right? And at one of these points, at a, let's say at a, the function approaches infinity. You have to take the limit, again, do the same thing as c approaches a. So you're just replacing a with a real number c that approaches a. And it's the same thing as you were doing up here with infinity, but now with another real number. So it's just replacing the b with the a with an actual value, just as we did before. So you'll do that. Alright, and so that's basically it. And also, again, if you have both sides, like a and b, and it approaches infinity from both sides, again, you want to split it up into two intervals, just as we did for the infinity and negative infinity and positive infinity. Alright, so if you have a and b and it approaches infinity on both sides of a function f of x dx, and you can split it at a point like C, just as we did before. It's exactly the same thing. And it'll look like that. And then again, you can use what you learned from before and solve these two as limits for where this function approaches infinity or doesn't exist. So let's try a few examples. And you must also, when you do these problems, you have to test for convergence. So let's just do some examples we know that converge, okay? So here's an example we know that already converges, so we're not going to do any convergence tests. I'll do a video on that perhaps later. But we'll just take this improper integral and solve it. So let me just erase this. Or, yeah, erase this. I'll leave some of this up here because it's basically the same stuff. And you have an integral from 0 to 4 of 1 over square root of 4 minus r dr. And this function looks something like this. I'll just give the graph to easily visualize what's going on. And at 4, this function starts to approach infinity. So we know that we have to replace this number here by a variable, or by a number that approaches 4. So we'll take this limit, and we'll say as a approaches 4, and then do the same integral from 0 to a instead this time, square root of 4 minus r dr. And now if you solve for this integral, and also you also have to notate whether it's 4 from the left or 4 from the right. So it could either be as a approaches 4 from the left, or as a approaches 4 from the right. And in this case, we know that you're approaching 4 from the left. So you're going from the left to the right, but you're approaching from the left. So you'll denote this with a negative sign here, because you're going this way from left to right. So you're coming from the left. So that's another important thing to remember, the sign. So continue with this as approaches 4 from the left, and you take the integral of this, and we know that we can just write this in a simpler form. So this is just 4 minus r to the negative 1/2 power, and I'm doing it this way so that we can use the power rule to integrate this. It'll be much simpler. And then when you do integrate this, you get negative 2 4 minus r to the positive 1/2 power from 0 to a. And this is still the limit as a approaches 4. And when we plug this in, right, when you have negative 2 and you have 4 minus 4, the square root of 4 minus 4, which is 0, so you get 0 there, and then rather you have to subtract minus, and you plug in the 0, so you get minus negative 2 times the square root of 4, which is 2 again. So you get a 0 plus 4, and this integral ends up being positive 4. So the answer to this integral, this improper integral, is 4. So there you have it. I'll be doing another video, another short example on the same topic next.